Hey guys, it's Sukrit from STEM Coder. Today we will be talking about an even more special kind of matrix, the reduced row echelon form. So as you may recall, in the last video we talked about the row echelon form, but today we'll be talking about the reduced row echelon form. It's an even more special and even more exclusive kind of matrix. So let's get started. Now, I've listed 4 points over here, and in order for a matrix to be reduced row echelon form, it must satisfy all 4 of these conditions. Now, conditions 1 or 2 are the exact same as what we had for row echelon form. The leading entries, so the leftmost non-zero elements, must be to the right of the leading entries directly above it, and the zero rows must be below all the non-zero rows. But there's 2 additional constraints that we must follow. All the leading entries must be 1, which means the leftmost non-zero element in every row, the leading entry must be 1. And number 4, every element directly above and below a leading entry must be 0. So let's talk about the last point a bit. You can clearly see that the 3 leading entries are 1. But watch closely. This column contains a leading entry, and look, except for this leading entry, everything else is a 0. Same thing with this column. This leading entry is a 1, but everything else is a 0. This column does not have a leading entry, so doesn't matter if we have non-zero and non-1 numbers. And this column over here has a leading entry, so except for this one, everything else must be a 0. So just to recap, the leading entries in a row must be to the right of the leading entries above it. 0 rows must be below all non-zero rows. Leading entries must all be 1. And finally, all elements directly above or below a leading entry must be 0. Let's draw some matrices and check to see if they are in row reduced echelon form or not. And by the way, we can abbreviate reduced row echelon form as RREF, because writing it out may take a lot of time and energy, so just abbreviate it as RREF. This matrix over here, 1 0 0 0 1 0 0 0 1, is the identity matrix. Pause the video and determine if this is an RREF or not. This matrix is in reduced row echelon form. Leading entries are to the right of the leading entries above it. Good. We don't have any 0 rows. All leading entries are 1. And finally, every column with a leading entry has zeros except for the leading entry itself. So above and below the leading entry, it's all zeros. Let's draw another matrix. 1 0 6 0 1 3 0 0 0. Is this matrix in row reduced echelon form or not? This matrix is in RREF. We got our leading entries. Yes, they're both 1s. Leading entries are to the right of the leading entries above. This column does not have any leading entries, so we can have non-zero numbers, but these 2 columns which do have leading entries, look, everything else is a 0. And finally, my 0 row over here is below all my non-zero rows. Now, what about this matrix over here? Is this matrix an RREF? No, it's not, because look, it's leading entry, it's not 1. Now, what if I change this up a bit? Make this a 1, and I make this a 1 also. Is this in reduced row echelon form? It's not, because look, this column has a leading entry, but it also has non-zero values above or below it. Look, this one, it's got to be a 0, because if the column has a leading entry, every value in that column except for the leading entry itself must be a 0. So hopefully you've got the hang of it. Remember, 4 conditions that must be satisfied in order for a matrix to be an RREF. Leading entries must be to the right of leading entries directly above. 0 rows must be below all the non-zero rows. Leading entries must be 1. And all elements directly above and below the leading entry. Basically, if a column contains a leading entry, all the values in that column except for the leading entry itself must be 0. So to finish up this video, I am going to draw a matrix which is in RREF. This one over here, 1 0 0 3 0 0 1 4 0 0 0 0. satisfies all 4 conditions. The leading entries being to the right, 0 rows being below the non-zero rows. Leading entries are all 1, and the columns which contain leading entries have 0 values except for the leading entry itself. I hope you found this helpful, and I look forward to seeing you in the next video.